Hey, good morning, everyone. Okay, before we get started, do you have any question?
Yeah, I actually have a question about the midterm.
Yep, Felicia, yes.
So our break is the 29th. It starts that week too, and I just saw that our midterm is on the 29th. So how are we gonna do that?
No, actually, if 29 is the spring break, then we won't have a midterm then. Let me see. Then we will postpone it, I guess, to April 5. Let me see. Or maybe we could do this. We could have a review on 22nd, and you could take the midterm on 24th. That's probably a better suggestion. But yeah, Kiana, yeah, that was really good point. Yeah, let me double check the academic calendar, right, really quickly. Let's see when the spring break ends. It's from April 4th. Okay, so that will work then. Then we'll do we're gonna have a review on March 22nd, and you're taking the midterm exam when you come back from the spring break, I guess. Okay, so let's
So
do
we
that.
won't take it on the 24th.
No, we won't. That's
Okay.
okay. Yeah. Unless you feel you maybe raise your hand. How many of you guys want to take the midterm on 24th? How about April 5th? Okay. All right. So yeah, I guess probably most of you guys prefer April 5th, so that when you come back from a spring break, then the only thing is that you probably want to spend some time by the end of the spring break and then study a little bit, right? So you can score better in the midterm exam. But yeah, let me just put down all those important dates just to remind you one more time. So March 22nd, Monday, we will have a review for midterm. I think review sheet has been posted in homework system. Midterm exam. And when you come back from the spring break on April 5th, so it's going to be the midterm exam. So you're take the midterm during the Zoom session, right? During the class meeting session. Yep. So this is two important dates. Okay. Mark that on your calendar and then keep a note. So, yep. So, any other question before we get started on the content? Okay. So you're gonna have a Excel project today, but I'll give you a demonstration before you get started. But let me just finish chapter 4, a summary of chapter 4. Let's continue on that. And there's some more important topics I want to mention before we wrap up chapter 4. Okay. Chapter 4 is mainly about probability and pretty useful if you apply to the daily routine, right? It's pretty useful concepts to have. So we actually talked about conditional probability. We ended conditional probability last time. So I want to talk about the fundamental counting rules. It's called fundamental counting rules. So let's say we have two events, event A and event B. If event A occur in m different ways, event A will occur m different ways. And an event B occur n different ways. And two events together could occur. The events together, event A and B. M times n different ways. So basically, these two events are independent events. So we basically applying the multiplication rules m times n different ways. Okay. Let me give you a really relevant example, like combination locks, right? Most of you guys probably use a combination lock. Let's say has 3 dials. Those 3 dials using digits from 0 to 9. And what is total number of combinations? What is the total number of combinations? And this matters, right? Think about it. If somebody try to, hack your lock, right? They will have to consider this, how many, like all those hackers, they try to hack into your password. They actually very much behave in the same way. So you need to consider the probability. They will do the same thing. They will consider the probability, like how likely they will be able to hack into your account or hack your password. Same thing with this combination lock, right? All these actually function in a very similar way. Combinations. Anybody want to give a shot? So you have 3 dials, right? Okay. This is first dial, second dial, third dial. Okay. And again, it's like if you're using multiplication, the fundamental counting rules. So first dial have 10 available digits, right? Between 0 and 9, there are 10 numbers. So using 9 minus 0, adding 1, including the first number. So 10 numbers between 0 and 9. So it means for each dial, there are 10 possible numbers available, right? So first dial has 10 possible number, second dial, 10 possible number, third dial, 10 possible numbers. So if you multiply all 3 numbers, using the fundamental counting rules, right? Multiply all 3, you get 1,000, meaning you have 1,000 combinations. So for somebody try to, hack your lock and try to unlock your bike or something like that, then it take a while, right? 1,000 combination, you take a while to do that. So the chances for to successfully unlock it at the first one trial, right, will be 1 over 1,000, right? So the probability is quite low. So 1 over 1,000, because the correct combination is 1, right? We have 1,000 combinations, 1 over 1,000. So the probability of unlock is pretty low. Right? Okay. But think about it. It's only 1,000 combinations. So it will, for example, if somebody have a lot of time to try the combinations, to keep trying, eventually the lock will be unlocked, right? Because the combination is not big enough. But think about it, if you have more digits, let's say 0 to 19, then each one has 20. So 20 times 20 times 20, each digit has 20 possible numbers. Then you have a lot more combinations, right? It will be 8,000 more. So that will lower the risk of being unlocked. Okay. And this is one of them. Think about this. Let's say we have 6 letters, right? Let's say arrangement of 6 letters. Let's say A, B, C, D, E, F. So we try to arrange those 6 letters. So how many total arrangement possible there? how many arrangements are possible? So now we have 6 letters, right? A, B, C, D, E, F. And now we have a 6 spot to fit in, right? This is first spot, second spot, third, fourth, fifth, and sixth. So first, second, third, fourth, fifth, and sixth. Now think about this one compared to the previous one. What's the difference? Anybody figure out the difference? So now you have 6 possible candidates, right? 6 possible letters, and we try to arrange it in a sequential order. Now think about this. For the first letter, right? You have 6 possible letters available, 6 candidates available. But when you move on to second one, when you move on to second spot, since you pick one of the letter, so there's only 1 letter left. I mean 5 letter left. So here you go. So 5. And similarly, when you move on to the third spot, right, third letter, you only have 4 possible candidates remains. And similarly, when you move on to fourth, 3 candidates remains, 2 candidates, and the last one will be 1 candidate. Eventually, by the time you get down to this, the last letter, only one letter left. Okay, so then you just multiply across, you're gonna get the total possible candidates here. So we get 30 times 24, right? 12 times 2 is 24. So we have total 720 possible arrangements here. And this is actually exactly what we call the factorials. So this process, multiplying 6 all the way to 1, is called a factorial. So basically, as you can see, 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. Okay, that's we get 720. And then another example could be, let's say we have a 10 factorial dividing by 6 factorial. Okay. So 10 factorial is going to be 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. Okay. And then 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. And the interesting thing is right here, everything after 6 will be canceled because they are identical, right? They cancel each other. So basically you end up with 90 times 70, I mean 56. Let's see what that is. So 10 times 9 times 8 times 7, that's going to be 5,440. Now, then also let's move on to a little bit more conceptual way of writing a factorial. Let's say we have n factorial. So n now is a number. It represents a number. So it will be n times n minus 1 times n minus 2 times n minus 3. So the factorial, the key thing about factorial is start with this number right here, n, and then keep reducing number by 1 until you reach the last number 1. So here you go, we keep going. And then the last two, if you want to put in dash, right, anything between the last 3 number will be 3 times 2 times 1. And that's how you expand n factorial in this case. All right. And any question on this about the concept of factorial? The factorial is developed by this particular content, right? By arrangement of certain distinctive objects.
I have a question, but it's not related.
Yeah, definitely. What's your question?
So this is Asma. My question was, I heard you saying that we're doing the project today. Did you mean the practice or the actual?
Oh, I will go over the practice project, and then you will be working on the actual project.
Okay, because I checked the calendar and it says it's through the 15th, not today.
Yeah, it's not today. Yes, I'll give you more time working on it. So
Okay,
yeah, you
sounds
won't be due today. Don't worry about it. Yeah. Okay, it's due next week, Monday.
okay.
So you have more time working on it. Yeah. Okay. All right. That's my. All right. And yeah, that's the factorial concept. And this, all of this is in the PowerPoint, right? You should be able to go over all these detailed concepts. I just want to bring up some important key points here, so help you understand it better. You know. Okay. So now let's move on to this. The last topic, actually, I want to mention in the chapter 4, it's called permutation combination, right? So then permutation and combination. So these two terms are very close with a slight difference, right? I'll point out what the difference is, permutations and combinations. So first of all, let's look at permutation rules. Permutation. So we have a n different items, right? So let's say we have 10 different students, right? That will be n different items, and then order does come, right? So then we'll pick k item out of n total items, and order matters. Definitely matters here, right? Because we're talking about people, right? So, and then this actually becomes permutation. So, n different items, pick k items out of n total items, and order matters. So that becomes permutation, and then we'll write it permutation as npk. And the formula will be the formula we use to calculate the permutation is n factorial over n minus k factorial. And again, we're using this important term factorial, right, to calculate the permutation. And meaning when we pick the k items, we rearrange those k items, right? That's why the order matters. Okay, so then let's take a look at the combination rule. Combination rule. You will still have n different items. We still pick k items out of 10 total items. And here the order does not matter, meaning we do not rearrange those k items after you pick them. Order does not matter. And this is the most important difference between those two. Order matters, order does not matter. Okay, so here, so we get combination rules nck. That will be n factorial over k factorial times n minus k factorial. Okay. You see right here, because we rearrange those k items, right? Put them in the sequential order. So that's why the difference between these two procedure is by the k factorial here. As you can see, the only thing difference is we divide combination rule by k factorial. Permutation we do not divide by k factorial because in a combination we do not rearrange those k items, right? You pick k items, that's it, right? There's no rearrangement happening here. go back, when we rearrange those 6 letters, right? It's like 6 items, 6 distinctive items. We get 6 factorial. See that? What if it's k letters, k amount of letters? That will be k factorials. So that's why they are closely connected to each other. So that's why I want to bring up this to you. Okay, then let's take a look at the example on this, and you understand why. Let's say a corporation, maybe college, right? The FIT has a board of trustees, right? The board of trustee at the FIT. I think usually they have 9 members for most trustees. For most colleges, they will select FIT as 9 members, meaning they decide on the college affairs, all the major issues happening in the college, they will decide. Each year, a 3-person committee is chosen. And okay, so here a 3-person committee, right? So for this 3-person committee, the board elects for this 3-person committee the board elects a president, a VP, right, vice president, and also a secretary. And this is first case. And how many slots of candidates for officers are possible? And part B, think of this. What if it's this, so for this 3-person committee, it is ethics committee, meaning it is an ethics committee. Okay. And it has no, like, you do not give a title for each person, right? So how many different three-person committee could be chosen? So first of all, we have 9 members, total 9 members, and then 3-person committee chosen. And then under 2 different scenarios, first committee here, the board has to elect a president, vice president, and secretary. That means we pick 3 items out of total 9 items. And then here we rearrange those 3 items, meaning the order matters, right? So let's say they pick 3-person out of 9 members, and the title of each person actually matters, right? So that's why rearrangement happens here. So this is what we call the permutation, typical permutation. And for the second part B, for this 3-person committee, it's just an ethics subcommittee. So there's no title assigned for each person. I mean, they just, all three persons have the same title, which is just committee member. So that's why here the order does not matter, right? We do not rearrange those three persons after we select them. So here, the order does not matter. We call this combination. So for the part A, we using the permutation formula. So here you go. Let's say it's, first of all, it's the original formula is MPK, right? So it will be n factorial over n minus k factorial. And in this case, n is nine total members, k equal to 3. So just plug in both numbers into the formula. So it's 9p3. Here will be 9 factorial over 9 minus 3 factorial. So it turned out to be 9 factorial over 6 factorial. Okay. And if you expand it, you can use calculator or Excel to do it, but you can also do it by hand. Here it's very straightforward. 9 times 8 times 7 multiplied by 5 all the way down to 1. Okay. And then for 6 factorial is 6 times 5, 4, 3, 2, 1. And again, as I mentioned, everything after 6 get canceled, right? They just basically multiply 9 by 8 by 7, and it turned out to be 504. We have 504 possible permutations available for this scenario. And then part B. So part B is a combination. So it's NCK, right? So it's n factorial over k factorial times n minus k factorial. Here n is 9 members. We're picking 3 committee members out of 9 members. So k equals 3. And here just plug in all those numbers. So 9c3 will be 9 factorial over 3 factorial times 9 minus 3 factorial. And then it's very similar, 9 times 8 times 7. 3 factorial, 3 times 2 times 1. And then 6 factorial here will be the same. Expand it all the way to 1. And cancel that. And it becomes 504 divided by 6. 504 by 6. That will become a lot less, right? It is 80, 84, 504 by 6. Yeah, 84, right? As you can see, a lot less combination available here. Now, if you multiply 84 by 3 factorial, meaning by 6, you get 504. So 3 factorial indicating rearrangement of those 3 committee members. Rearrangement of those 3 members. All right, and let's go back to, remember I mentioned at the beginning of last class, I mentioned those lottery games, right? Let's say I pick 5 lottery games. Let's say in New York, pick 5 lottery games. Actually, if you play any lottery games, you know that you pick, let's say you have let's say 60 numbers available to pick. And the question is, what is probability of winning the lottery game? Winning the New York Pick 5. So basically you're picking 5 numbers, right? It's big 5. So picking 5 numbers out of a total 60 numbers. And then here, does the order matter? Anybody have idea? Does the order picking those 5 winning numbers matter?
No.
No, it doesn't matter. Very good. Yes, it doesn't matter. Meaning, as soon as you hit those 5 numbers, the order you pick them does not matter. You win a game. That's why sometimes when you watch the news, right? They are nice. For some lottery game, they have like 10 winners or 20 winners, because they probably pick the same number, right? But with different orders. That's why we have 10, 20 winners sometimes. That's very possible because all those people pick the same number, but in different orders. So that's why they are winners. Okay, as long as you pick the same number. So here, think about this. First of all, you will see how many possible combinations available here, right? So we talk about a combination of picking 5 number out of 60 total numbers, right? So 60 sees 5. And this is not easy to calculate it by hand, right? So you probably want to use a calculator, and I'm going to show you how to get it in Excel. Okay, let me open Excel. Also in the calculator, that usually has a, you can just put in the first number and then 60 and then pick in the last number 5. And under the probability option, you'll be able to get a result. But I can show you how to get that in Excel very quickly. Both combination and permutation. Let me share the screen with you. All right. Go. So for combination, okay, so here we have a, okay, will be 60 C 5. Okay, so here goes. So the formula we are using will be COM EIN. This means return, we just put in combination, the first 6 letters of the pronunciation of combination, and return number of combination for given number of items. Okay, open parentheses. So we have total 60 numbers. Now we're picking 5, right? Out of that. Then we get a total combinations available here. Look at that. So meaning 5,461,512 total combinations. Now, what if it's permutation? Let's say it's 60 P5. Okay, that's a permutation, and do PERMUT. Okay, this PERMUT is the first 6 letters of permutation. Open that and then put in the 60 first and picking 5. Now we get a permutation with a lot more, right? A lot more permutations available under the same circumstances, because we rearrange those 5 numbers afterwards to make the possible outcomes a lot more. So this is what we need, right? So it's 5,461,512 total combinations available. So let's go back. So this is 5,461 and then 612. Okay. Total combinations available here. And think about it. How many winning numbers are there? Anybody have any idea? What is amount of the winning number for any lottery game, right? Or Mega Million, any games you're playing?
I'm sorry, do you mind just repeating the P formula?
Yeah, sure. Let me go back really quickly. Can you see the Excel?
Yeah.
Okay, sure. PERMUT, right?
Thank you.
So 5,461,512. It's 512, not 612. So let me just go back a little bit. $461 and 512. So again, any lottery games, right? You may have multiple winners, but they are picking the same number. So the winning number is always 1. So basically the probability of winning is 1, a number out of 5,461,512 numbers. Total possible permutation is available. And this probability will be very, very low, right? We can go back to the Excel, get a result. So the probability of winning will be 1 over this number. And this number actually is very, very small. Okay. Let's get that really quickly, get the exact number really quickly. Let me format it and then turn into decimal numbers. Okay. All right, so I guess I'll run it to this decimal. So it's 0.00000018, right? So this means 1 in about 2 in 1 million chance you will win the lottery game, right? This pick 5 lottery game. So the chances are pretty low. And this is a reality for most of the lottery games. You know, the chance of winning is always very, very low. But again, you know, although the chance is very low, but still somebody wins the game, right? And that always happens. Okay. Yeah, so that's actually, you can basically use this procedure to calculate any like lottery games you are interested in, or any, when you go to casino, right? All those like gambling machine, right? The probability of winning, you can always calculate it. Once you know all that possible, you know, combinations available there, and the winning number is always 1. So then you'll be able to find out the actual probability of winning that game, or winning the lottery games, all those different like instruments out there. Okay, that's pretty much everything I want to talk about in chapter 4, and then I will quickly do some lecture on chapter 5. Right? Just go over some of the important concepts in chapter 5, and I get you started on the Excel project number 3. Okay. Yeah, so the chapter 5 is about the discrete probability distribution. Okay. Maybe open new summary of chapter 5. Chapter 5 is discrete probability distribution. And basically, we take a look at discrete random variable, and then the distribution formed by the discrete random variable. Discrete random variable. So basically, discrete random variable is a variable. Typically, we're using X to represent this variable that has a single numerical value that has single numerical value occurring by chance, right? Numerical value occurring by chance for each outcome of a procedure. I'll give you a very simple example, right? Let's say if you flip coin 3 times, and then count number of heads show up. Then you'll be able, basically we come up with a discrete probability distribution here, right? So think about it. The possible outcomes could be, I'm releasing the table. We have a, so this is possible outcomes, possible outcome. Possible outcome has four major categories, right? You have 0 heads, 1 head, 2 head, 3 head, right? That's all. And then associated with that will be the probability of for this to occur, right? Probability of this. So this is a random variable X we're talking about, which is discrete random variable. And we never know, what outcome we'll end up with, right? They're all possible. 0 head, 1 head, 2 head, 3 heads with different probability. And we'll be able to find out what's probability of getting 0 head, right? Getting 0 head meaning all 3 tails. So the probability of that will be 1/8, right? Again, if you want to know all these possible outcomes, 0 head, all tails, right? 3 tails. 1 head, so head could be on the first spot. So head, tail, tail. Head could be on the second spot. Tail, head, tail. And then head on the third spot, right? Tail, tail, head. So that means 3 out of 8 out. 3 outcomes out of 8 outcomes. 3/8. If it is 2 heads, that meaning 1 tail. Tail on the first spot. Tail on the second spot. Tail on the third spot. So again, 3 outcomes out of 8. So 3/8. And the last outcome will be 3 heads. So head, head, head. And we know that it's total 8 outcomes here. 8 outcomes. We can also use a fundamental counting rules, right? Like first trial, second trial, and third trial. First trial, 2 outcomes, head or tail. Second trial, 2 outcomes. Third trial, 2 outcomes. Multiply across, you get 8. Okay. That's why we have 8 outcomes. And the last one, head, head is 1/8. And this is exactly what we call a discrete random variable, right? It's a single numerical number occurring by chance. This is what we mean by occurring by chance. Have different probability associated with it. And also, if you sum up this probability, it will be 1, right? So the total probability here, it's sum up 1/8, 3/8. That means we're including all the possible outcomes. So the probability becomes 1. And this exactly explains what is a discrete random variable and also discrete probability distribution. This is what we're talking about for this major topic. So here the probability distribution is basically a graph or table, right? A formula that gives the probability of each value of the random variables. Here we're using a table to represent all these random variables, discrete random variables from 0 all the way to 3 with the corresponding probability. Okay. So this is one of the case. And also think about, let me give you some example of the more discrete random variable, like discrete random variable. It could be a number of people attending Columbus Day Parade, right? Number of people. Columbus Day Parade. Although it's going to be a lot of people, but it's still finite, countable, right? So the important concept is finite and countable. Finite countable numerical value. Here must be a numerical number. Let's say it's 150,000 people, or maybe 10,000 people, right? It's a finite, countable, and a numerical number. Those are the key aspects of the discrete random variable. Or another example could be number of eggs and lays per day. It could be anything between 0 to 20 eggs, right? Let's say, then again, the chances for each outcome to occur will be random, right? And also we have a finite countable and numerical numbers representing those eggs, possible outcomes of eggs. And also another concept is called continuous random variables. And then starting on chapter 6, right, we're gonna look into the continuous random variable. And the continuous random variable basically concept has infinite many data values, infinite many values available. So basically you are given a interval, and then anything between the interval are possible. And then values without gap between them. And let me give you an example. So let's say amount of milk a cow produces a day, right? This is very good example of a continuous random variable, amount of milk. A cow produces per day. Let's say you have a range between 2 gallon, right, to 3 gallon. And then for any given day, anything between are possible, right? You may have a, let's say on one of the day, the cow produced 2.14 gallon of milk. Maybe on the next day, it produced 2.145 gallons of milk. And you just list it, and then every day, it produce different amount of milk gallons, right? That means anything between 2 and 3 gallons are possible. And we have infinitely many values there we can come up with. So this is exactly the concept of, so we have infinitely many values with a chance to occur, okay? And also like another good example is humidity. The humidity at any given day, in a single, at a given day, right? Humidity. Or any temperature, something like that. Temperature is also a very good example of a continuous random variable. Also, if you invest in the stock market, another example could be the daily closing value of the Dow Jones Industrial Average Index. Closing values of Dow Jones Industrial Average. And let me show you this. I could show you the Dow Jones Industrial Average. Let me just go to Google, and then let me show you that. Okay. So you go to any finance session, right? Any finance session, and we click on the index fund. Let me share the screen with you. If you look at the Dow Jones, Dow 30, And if you look at this, all these different, like let's say I pull 5 years, you know, all these values, you're gonna see a very, you see, this is exactly what we're talking about. The continuous, you see, it's within the range between this all the way to this, right? So it has a range, but anything between are possible. You see that? So you have infinitely many values available here. So that's exactly the notion of the continuous random variable. Okay. Make it bigger, and then you can see better graph here. And the interesting thing about this continuous random variable is it's applying in a lot of different fields. You see, and if you can, there's a course called time series analysis. You'll be able to analyze the trend of this the graph and then make a prediction towards the next moment. And that's what Wall Street is doing, right? They're basically analyzing all these historical data and then try to make prediction about the future values. And if you make a good prediction, they could profit out of it, right? They could make a profit of it. So it's very good. And it basically just comes from the very original concept of continuous random variable. And by studying chapter 5, and you're gonna get a lot more idea about these two different variables. Okay, which is one of the examples. So all the continuous random variable, when we graph it, right, you're gonna see a graph like this, right, up and down graph, but it's gonna be, it will be within the range, right, within the interval. Let's say this interval here, there's upper bound, lower bound here, and anything in between are possible, right? It's constantly move up and down. That's a key characteristics of the graph. We will see from all those continuous random variable. Okay, and let's go back. I'll just show you one of this real life example. You know, we can utilize that. Also the temperature, right? If you look at the temperature at any given day, it always move up and down within a certain interval, a certain range. Okay. And so that brings us to the requirements of the probability distribution. So no matter it is the discrete random variable or continuous random variable, they usually satisfy this, they must satisfy this probability distribution. So the requirements of probability distribution. In chapter 5, we concentrate on discrete probability distribution. Two things. First one is total probability here. We sum up all the total probability must be 1. And for any given probability must be between 0 and 1. So once any probability distribution, any distribution satisfy these two conditions, it becomes probability distribution, right? And then discrete probability distribution also follow this. If you, as you can see, if you go up a little bit, the one we generate here, it's a discrete probability distribution, and we calculate the total probability here is 1. And also, if you look at each individual probability here, it's definitely between 0 and 1. So this one is a probability distribution, greater equal to 0, less equal to 1. Okay. So it satisfies both conditions, and we call this a probability distribution. And this is actually the formal concept of probability distribution. And for probability distribution, we'll be able to calculate the mean and standard deviation from it, right? So for example, let's say if you look at so the mean for the probability distribution is basically mu equal to summation of x times p of x. So you basically create a column x times p of the product of a discrete random variable times the corresponding probability, and you sum up the product. That's the mean. And then the standard deviation of probability distribution will be standard deviation sigma equal to square root of summation of s squared times p of x minus mu squared. Okay. We'll check the formula really quickly. Yeah, that's right. Okay. Now that's the standard deviation to calculate the probability distribution. So for example, we know that for the example I bring up about the heads of the flipping the coin. So the x, p of x, we have 0, 1, 2, 3, right? Okay. And then the last one will be total. And we have the probability is 1 over 8. If you want to turn into a decimal number, you can do that. That'll be easier, slightly easier to do that. So 1 over 8 is 0.125. 3 over 8, 0.375. Okay. 3 over 8 is 0.375. And 1 over 8 is 0.125. Okay. And then in order to find out mean, we just multiply the x times p of x. Okay. Product of the discrete random variable multiplied by probability. So 0 times 0.125 is 0. 1 times 0.375 is 0.375. 2 times 0.375 is 0.75. And then 3 times 0.125 is 0.375. So the mean, as you can see, if you sum up this total of this column here, summation of x times p of x will be 1.5. So what this means is, on average, if you flip a coin 3 times, you expect to have 1.5 heads, right? Because the probability of getting head is 50%. Probability of getting tail is also 50%. That means on average you get 50% of 3 heads. So it's 1.5 heads. So this mean actually explains average outcome, right? Meaning on average, what kind of outcome we're looking at, right? Meaning we expect to have 1.5 heads in this case. And standard deviation, we need another column, which is x squared times p of x. So we need x squared times p of x. So you can just square the x, right? So it becomes 0. X squared is 0 and 1 and 4, 9, right? And then multiply by probability of that. 0 times 0.125, that's 0. 1 times 0.375, that's 0.375. And 4 times 0.375, should be 1.5. But let me double check. Yes. And that's 1.5. And 9 times 0.125. And that turned out to be 1.125. If you sum up all of that, then we're going to get this portion called x squared times p of x. Right? See what that is, 0.375 adding 1.5, adding 1.125. That turned out to be 3. Okay. So now we have a mean. We have this element here that we'll be able to calculate the standard deviation. So it will be x3, right, minus 1.5 squared, because mean is 1.5. So this becomes 3 minus 2.25. So we get square root of 0.75. This is approximately, let's run into 2 decimal place. And that turned out to be 0.87. Okay, so the standard deviation here is 0.87. For this particular discrete probability distribution, right? Discrete probability distribution. So first of all, we make a determination using the requirements here for the discrete probability distribution. Then once those two conditions are verified, then you'll be able to calculate the mean and standard deviation of the probability distribution. Okay. And I think I will stop lecture here. Now let's go to the Excel project. Right. So let's open the Excel project number 3 practice. Go to the Blackboard and let's look at the practice sheet first. Okay. And I'll show you how to walk through, right? And then you'll be able to work on the actual project. So go to Excel project practice and open this file called Excel project number 3 practice. Okay. Now let's open the file. Okay. And the question number 1 is about, actually you probably have this in your homework assignment. It's find the mean and standard deviation from the frequency table, right? So you have frequency distribution table, and then you want to find out the mean and standard deviation. First of all, let me remind you where to find the formula. So the formula come from the Blackboard. Under the formula sheet, you can find all the formulas over there. So you go to formula sheet and I open the formula sheet. And from there, all the chapter 3 formulas will be here. Okay. So we have a standard deviation for frequency table, right? That's where it is. And also have the mean, right? Mean for frequency table. So we're using these 2 formulas. Okay. To calculate the mean and standard deviation. Now let's go back. And for that formula, probability distribution formula, if you look into the chapter 5 formulas, you see this is probability distribution, the mean for probability distribution, the standard deviation for probability distribution. Okay, both of them. And then next week, we're going to talk about binomial probability distribution and how to find the mean standard deviation of binomial probability distribution. But yeah, we'll talk about that next week. And yeah, let's go back. So we have all these formulas needed. Let's go back to Excel. So first of all, in order to find out the mean, we need to create a product of frequency times the midpoint. So question 1, the midpoint is already given, right? Compared to question 3. For question 3, the midpoint is not given yet. Okay. So that means we need to find out the midpoint first, right? For question 3, and then go from there. But for question 1, it's already there, so we can just go straight to it. So first of all, you multiply f times x. So you multiply the midpoint by the frequency, like get all these numbers. Then if you sum up that total, right, meaning sum up this column, total sum, yeah, you get that. Now the mean is a summation of f times x, which is this, by the total frequency. So we haven't calculated total frequency yet, so that add up all the frequencies, we'll end up with 47. Total frequency means a sample size, so they are the same concept. So we're using the total of the product f times x, okay, dividing by total frequencies, and then we get the mean.
Do you mind just clicking on one of the f of x squares, the 400?
Oh yeah, sure.
Thank
I
you.
just multiply the B4 by C4, right? Multiply by the midpoint by the frequency to get that. And once you have one of them, then you can just drag it, right? Just put a cursor on the bottom right-hand corner, see the solid clause, and you drag it, you get all these numbers. And in order to calculate the mean, sum up the product. Okay, look at that. Or if you want to do using the formula, you can do sum, open parentheses, highlight all those previous numbers, D4 to D9, and then key enter, right? You get that. Same thing here. If you do not want to use a shortcut, you can just type in the formula, sum, open parentheses, highlight all the frequency numbers, then key enter, you get 47. And the quotient of those two becomes the mean, right? And we also need to calculate the standard deviation. So for the standard deviation, we also need this item called f times x squared. Okay. So what you can do is multiply the frequency C4 times midpoint square, right? 80 squared. Okay. All right, I'll give you some time to try that yourself. Frequency times midpoint square. Then once you get one of them, you just hit enter. Okay. Then just drag it, right? Drag the formula to the rest of the calculation. Then we'll be able to get all these numbers. Then from there, you sum up the total, auto sum. Look at that. So now we're gonna calculate the standard deviation. We
Sorry, can you click on one of those squares again?
one of the squares, sure.
Yeah, the 3.
This one.
That's good, thank you.
Okay. And yeah, I actually post a solution, so you don't have to worry about this. If you do not catch, just try to make sure you follow through the procedure, right? I actually post a solution already in the Blackboard. But yeah. All right, so get one of them, then you'll be able to drag it, right, to get the rest of them. And then sum up that. And then from there, again, we basically just follow the formulas. So we go back, we need this. We need sample size times total of this product of frequency and then midpoint square, and minus total of frequency and the midpoint, and square that outside. And then divide by sample size times sample size minus 1. And that's how you get a standard deviation for the frequency table. And again, we follow exactly that. Let's go back to the Excel. Now we're going to do square root, right? Open parentheses. And for numerator, you're going to put into parentheses. So we're using sample size 47 times summation of f times x squared, okay? And minus summation of f times x squared that. So that becomes the numerator, and dividing by denominator, which is 47 times 47 minus 1. Okay, then close that, close one more time. Then you input this formula in the Excel, then you'll be able to get the square root, the standard deviation of this frequency table. And the total, turn out to be 4.22, right? If you run it to 2 decimal place, we can do that. Just trim it down to 2 decimal place. Okay, we get that over. Okay. Any question on this? Okay. Now, find the mean and standard deviation of x. Yes. Question?
Would you go a little bit slower on this one?
Yeah, sure, definitely. You mean the question number 2?
Thank you.
Okay, sure, definitely. So this one, we have a probability distribution, right? If you look through this, we have 6 different discrete random variables, 80, 83, 87, 78, 90, 92, right? All those. And then one of these probability is missing, right? You see, for probability for discrete random variable 92, it's not here. And how would you find that? There must be a way to find it, right? Remember, the total probability for the probability distribution is 1, right? So if one of them is missing, we'll be able to find it, right? By using 1 total probability minus sum of the previous 5 probabilities. Okay, then we find the missing probability for the random variable 92. Okay, that's the most important step. Here. So we hit enter and we get that. We get the probability, which is 0.04 for the discrete random variable 92. Okay, one more time, this is the formula. Total probability 1 minus sum of the previous 5 probabilities. And we get that, 0.04. Now, next thing is finding the, in order to find the mean, we need this x times p of x. Meaning x is the discrete random variable multiplied by the corresponding probability. Exactly like what we did by hand right earlier here. Same thing, right? We just do it step by step by hand. And here we're using the Excel to do it. Okay. Here we go. So we multiply x by probability of that. So B17 times C17. I'll give you some time to catch up on this. Then if you hit enter, okay, you get that. And then similarly, you don't have to do it one by one, right? Just you see the green box pops up, and you click on that cell D17 and put a cursor on the bottom right hand corner, and you see a solid cross. Okay, then you just drag the formula all the way to the last row. Okay, you get all these product. Then the mean is basically the sum of that, right? The sum of all these product. Okay. According to the formula, right? You just sum up all the product, and that becomes the mean for this probability distribution. Okay. And once you do that, then you hit enter, you just get the result. Okay. And the mean turned out to be 85.77. Any questions so far? All right, now let's move on to standard deviation. So we need this item called x squared times p of x. Okay, meaning we need to square the x, right? And then multiply by p of x. So how we do that? Using a cell, this cell B17, square that, multiply by cell C17. Okay. Again, I'll give you a couple of minutes, some time to catch up first. X squared times P of X. And once you have that, then you just hit enter. Okay, then we get one of them, and then just drag it. Again, drag the formula all the way to the last cell down there. And get all these products, right? Square midpoints, the discrete random variable square times probability of that. Then we have all of this And then once you have this ready, then we'll be able to calculate the standard deviation here using the formula, right? So the formula is this one. Go back, standard deviation for probability distribution. So sigma square root of sum of x squared times p of x minus mu square minus mean square. Okay, and we'll go back here. So we need a square root first. SQRT represents square root, open parentheses, and we're gonna do this, right? Sum of this. So I guess it's easier to calculate the sum first, right? So sum up this here. Okay, and sum up this as well. That's a mean. Okay, 35.77. So sum up those two first. The last two columns. Now we start to calculate that. So using square root of this cell E23 minus cell D23 and then square that. Okay. And then we, once you have input that, you're good to go. Just hit enter and make sure you calculate the total of the last two columns. And once we have that, then we're good to go. Right, just hit enter and get a result. Should be about 3.55 if you run in 2 decimal place. Okay. Then we have it. And for question 3, I want you to try yourself. You see, you want to find the mean and standard deviation of x from the frequency table. So very similar to the question 1. The only thing here is the midpoint is not given, right? So you need to create a column called midpoint here. And midpoint is the middle of those two numbers. So the first midpoint will be 30 plus 36 divided by 2, right? You get one of the midpoints and you get rest of them. Now you follow procedure, get a product f times x, right? And then f times x squared. Okay. I want you to try this yourself. So the question 3 is like a little bit more complicated version of question 1. The only thing here is the midpoint is not given. Question 1, the midpoint is already given. But here we have classes. So you can utilize the classes to get a midpoint for all these 6 classes. And from there, calculate product. And then find the mean standard deviation. Let me give you some minutes to work on this. Okay. Try that yourself so you learn from it.
Can you just click the box under X?
Okay, the midpoint, right? You're taking the first number, adding the lower class limit, adding the upper class limit, dividing by 2, right? Close parentheses divided by 2. This is what we call the midpoint. You can ignore the sheet 1, right? Sheet 1 is not needed. Okay, if you want to delete it, you can delete it. Just focus on sheet 2. That's 2. All right, let me just go over the solution with you. So we get a first midpoint. All right, so then we could just continue get all the rest of the midpoint. All right, so second one will be 37, adding 43, and divide by 2. Okay. All right, we get that. Then the difference must be 7 because the class width is 7 here. Between 37 and 30, the difference is 7. Between 43 and 36, the difference is 7. That means class width here is 7. So the midpoint should be differ by, should be differ by 7. Okay, so next one must be 47, right? So let's run through the calculation and see if that confirms. All right, so divide by 2, it turned out to be 47. Next number, similarly, 51 plus 57 divided by 2, 54. Okay, next one, 58, adding 64 divided by 2. Of that, and the last one is 65, adding 71 divided by 2. Don't have all of that, all the midpoint. Now we need a product of frequency times x. And if you want to change this to f, we can do that, right? Because frequency. So multiply cell C31 by cell D31 to get a product of those two, frequency and midpoint. From there, he enter. Okay. And now once we have one of them, okay, we can just drag the formula to the rest of them. To get a product, we also need another product, which is frequency C31 times D31 square, right? Square that, we get that. Then once you have one of them, you should have the rest of them. Now, we need 3 total, sum of the frequencies first. Okay, get that. That's a sample size we are using here. And then we also need a product of the frequency and then the midpoint. Get that. And also the last one is this. Okay. Now we have all this ready. Then the mean is sum of the frequency times midpoint 1198 divided by the total frequency, the sample size 24. Then you get a mean. Okay. I think running 10.
Wait, I'm sorry. Do you mind slowing down just a tad?
Okay, you mean this one? So the total of the product of frequency and the midpoint 1198 dividing by the total frequency, which is 24. Yeah, that becomes a mean, right? Again, all these come from the formula, right? We did not deviate from the formula. When we strictly apply the formula, total of frequency times midpoint divided by total frequencies. That becomes the mean of the frequency table. And then standard deviation comes from this formula here. Now go back one more time here. The quotient of those two, 1198 and 24 becomes a mean. And for standard deviation, square root first, right? Open parentheses, open another parenthesis for numerator. So we're gonna need this total of this column here. We already have it, it's F37, 61,556. And before that, we need to do sample size C37 times the product of those two, total of that. Yeah. F37 minus product F frequency times midpoint, square that. And that will take care of the numerator. Okay. Then we divide by the denominator. It's this multiplied by this minus 1. and close the denominator using that purple or orange, parentheses, and then close the outside, the most outside parentheses using the black one. Then we have it. Then if you enter, you get a standard deviation. And again, you expect to complete everything in Excel, right? Do not do it in a paper or use a calculator to calculate the result, and then you input the result here, right? You have to use you have to use Excel to calculate each one of these, right? Step by step. You have to receive a perfect score, right? That's the whole point of using Excel to do all the exercise in Excel projects, to help you get used to all these different calculations using Excel. Okay, this is very useful techniques, skills to have. Do you have any question on question 3? Okay, one more time. In general, right, for all the Excel projects, you have to use a formula in Excel, right, as much as possible. Try not to use any calculator or by hand or any other technology. Just use Excel, right? Try to calculate everything as much as possible using Excel. Okay. And if you have no other question, I guess you could start working on the Excel project number 3. You go back to the Blackboard, and then the actual project is under the Excel project submission. It's due by next Monday, so you have to, if you cannot finish today, that's okay, right? We still have about 20 minutes. If you want to work on it, it's very similar to what we have. It's already input in Excel file. So you just have to follow the procedure you just learned, right, step by step, and you'll be able to get all these answers here. Okay. All right, so if you have no other question, you could get started, right, on this project. Meanwhile, I'll put you in a breakout room. So if you have an individual question, feel free to ask me. And also, one more time, if I did not respond to your request to join your breakout room, that means I'm with one of your other classmates. When I finish with your other classmates, I will join your class breakout room. Okay. So that's a queue, right? That's a queue on the breakout room, request. Okay. Go ahead. Hey, Neil.
Hello.
Hey.
Hi. I just have a question. Do you mind if I share my screen quickly?
Definitely, go ahead. Yeah, sure. Yeah.
Okay.
Okay.
So this is my Excel project so far. I was a little confused, but the first 2 questions are the same, pretty much, right?
No, they're not the same.
Oh, because like for me, it's the same numbers.
No. The probability is different, right? Yeah, the number may be the same. Yeah.
Okay.
Probability is different. Yeah.
I was confused about this. Is this correct?
What is? Yeah, I think so. Yeah, it's a frequency times. No. Hold on. D7 square. What is? No, it's not D7 square, right? It's B7 square, right? X square. F times X square. So not D7, but B7.
B7.
Yes, which is midpoint.
Oh, this.
So, yep, exactly.
Oh, so, but still C first?
Yeah, you can do that. C7 times B7 squared. Yeah.
And then, okay, sorry, one more question. 1 second. So that looks more right.
Yeah, that looks good. Yes.
Okay. And then for down here, same question with this. Is that what I'm doing?
Yeah, will be the same, right? The frequency times midpoint square. So frequency is a C33 times E33 square.
Wait,
Ah,
C30.
C33, right? C33
Wait. So C33
frequency times
times
midpoint
X
square. Exactly.
squared. And
Why you drag it?
then this is just the sum of all of them. Okay. So this one and this one look good so far. I just have to do the standard deviation in question 2.
That's right.
Okay. Okay. Thank you so much.
No problem.
Sharing and try to reshare my
Yeah,
screen
reshare, please.
because you might